This is Intermediate Algebra video lecture number 14 on intersections, unions, and compound inequalities. Definition to kick things off. Intersection. If A and B are two sets, so we have A and B, they're sets containing elements, then we say the intersection of these two sets, and the way you would denote that you're taking the intersection of these two sets is you would write A intersect, it looks like an upside down U, doesn't it? B, that intersection is the set of all elements that are common to both. Where they overlap. All right, you might have seen this illustrated with the Venn diagrams as well. I'll throw one in there for you if you like. So here, let's look at an example. Find the intersection. We have one set. You can think of that as set A if you like. 1, 3, 5, 7, 9. And then notice we're taking the intersection of that set with the next set, B, 1, 2, 3, 4, 5. So the intersection A intersect B is going to contain what elements? Well, what do they have in common? Where's the overlap? Well, notice they both contain 1. So throw that in the set. There we go. What else? They both contain 3. Okay, that goes in there too. Anything else they have in common? Looks like they both have 5, and then that's it. Okay. And like I mentioned, if you've seen this with Venn diagrams before, so say this is set A, and then this is set B, this portion right here in the middle where they overlap is A intersect B, what they have in common. Okay, good. Now we're going to add on to this idea. A conjunction. In mathematics, a conjunction is anytime you have two statements that are joined by the word and. That's a J. Let's make it clear. Joined by the word and. All right, so here we go. Example. Graph and write interval notation for the following conjunction. X is greater than -7 and X is less than -2. So to kick things off, let's draw our number line so we can graph this. We've got -7 and -2. Now notice it says the first inequality, X is greater than -7. So if I were to graph that, X is greater than -7. Notice it's just strictly greater. It's not greater than or equal to. So I'm going to put parentheses and then shade to the right. And X is less than -2. So X is less than -2, parentheses at -2. And then I'm going to shade to the left. Okay. So where is the overlap? Or where do you see on the number line both blue and purple being shaded in? Notice we have a conjunction here between these two statements, right? The word and. So and means you're going to be looking for the overlap, what they have in common. So where do you see both purple and blue on the number line? Good, right here between -7 and -2. Can you see it? Okay, so to summarize now, the final solution for this conjunction is the interval starting at -7. Notice I'm putting parentheses because we're not including that endpoint, going up until -2. Parentheses again. Beautiful. All right, if you need a review on when to use parentheses, when to use brackets, interval notation, then go ahead, watch the previous video, which was an introduction to all of that. All right, now notice that the solution to this compound inequality could be abbreviated. So instead of writing out x is greater than -7 and x is less than -2, we could have just written -7 is less than x is less than -2, right? So instead of writing two inequalities with the word and, we could have just written that one compound inequality. All right, so here we go. Let's try a few more. Solve, graph, and then write your solution using interval notation. So example A, we have 5 is less than 2x plus 1 is less than or equal to 19. So when you're solving an inequality that looks like this, a three-parter, you want to try to get the variable by itself in the middle. So whatever you do to get it by itself, you have to do to the other two parts of the inequality. So to start off, let's subtract 1. So we're going to have 4 is less than 2x is less than or equal to 18. And then next thing I need to do is divide through by 2. So we're going to have 2 is less than x is less than or equal to 9. And notice the variable's isolated. So now it's just a matter of graphing this. All right, not too bad. So let's draw our number line. I'm going to put 2 and 9 here. And then notice we're not going to include 2. So on the number line, I'll put parentheses right there. And then 9 is included, so I'll put a bracket, and then we just shade in the middle. All right, and then to write it in interval notation, just use your graph to help you, right? So you're going to start at 2 with parentheses, put a comma. That means fill everything in, and then 9 with a bracket. Voila. Good job. How was that one? Good, let's move on to example B. So we have x plus 3 is greater than or equal to 4 and 2x minus 4 is less than 6. Okay, this time we're going to solve each of them separately and just keep writing the word and as you work through each line. So the first one, not too bad, I can just subtract 3 and be done with it. So we've got x is greater than or equal to 1 and for the next inequality, I'm going to add 4. So we have 2x is less than 10. So I've got x is greater than or equal to 1 and dividing by 2, x is less than 5. Okay, so let's graph these two and then see where the overlap is. I'm looking for the overlap because notice we have the word and between them. So here's 1, here's 5. X is greater than or equal to 1. So we will put a bracket and shade which way? Yes, good, to the right. And x is less than 5. So I'm going to put parentheses. Why parentheses? Yes, because it's strictly less than 5, not less than or equal to. And then shade to the left, to the left, to the left. Okay. Where is the overlap? Where do you see both blue and purple on the number line? Why, yes, right here in the middle between 1 and 5. Now make sure you write out the final interval notation properly. Bracket on that 1, parentheses on the 5. Yes? Did we get it? Good, I'm so excited. Fabulous. Okay, looks like we've got conjunctions under control. Let's move on. Next idea, unions. All right, if A and B are sets, then the union of A and B, and the way you would write that out is A union B, is the set of all elements belonging to A or to B or to both. So let's look at an example, and then I can draw you another Venn diagram if you like. Okay. So find the union of these two sets. So the union is putting everything together. You're joining it all up. Joining, okay, think of it that way. So the union, if I call this set A, call this set B, A union B would be, well, let's see here. Let me just list out everything in A. 1, 3, 5, 7, 9. And then let me now look at set B and see if anything got skipped. Okay, 1's in there. Oh, 2. Let me add him in. It's the union. We're just going to add everybody in. All are welcome. 3, no. 4, oh yes, 4, come join us. It's the union. It's time to just include everyone. 5, no. We already got it. Okay, so you don't need to list your duplicates. If it's in the set, it's accounted for, we're good. You don't need to list them out twice. Okay, now, Venn diagram time. Here is set A. Here is set B. They may or may not intersect. You want them the same size? It doesn't matter. Okay. Here's set B. The union is everything together. Okay, so the union is what I'm shading for you right now. What is in one set, the other set, or both. So that purple shaded area is A union B. The shaded stuff, okay? All of it. Fabulous. Okay, now let's add on to our vocab. Who knew you would do so much vocab in math? But here it is, it's happening. Disjunction. What is a disjunction? It sounds kind of angry. It's when you have two statements. Joined by the word or. Okay? When you see or, it means union. Join them up. Here we go. Graph and write interval notation for x is less than -5 or x is greater than 1. Here we go. Here we go. Number line. Hello, number line. Here's -5. Here's 1. Okay, x is less than -5. Parentheses or bracket? Good, parentheses, because it's less than -5, not less than or equal to. And which way will I shade? Yes, to the left. Very good. Include that arrow. Beautiful. Or x is greater than 1. Parentheses or bracket? Very nice. And shade which way? To the right. Good. Get that arrow. Okay. Now notice this is a disjunction. So I have the word or between. So when you write out in interval notation the solution for this, you're going to list everything that you see shaded. So you're not looking for overlaps, you're just looking for anything that's shaded on the number line. It goes in the answer. Just like on the previous example, we just put everything all together in one big set. Free entry for all. So same thing here. You're just going to list everything you see. Well, I see two separate shaded parts on this number line. Do you agree? Here's the first part that's shaded, and here's the second part that's shaded. So guess what? We have to write two separate intervals. There's no way around it. The first one always has to go in increasing order, okay? So always go left to right, small to big. First interval starts from -infinity, goes up to -5, parentheses, and then we're going to put union. Sometimes you'll see people write the word or, but do union. And then the next interval starts at 1 and goes to +infinity. There's no way to write this as one interval because notice for this disjunction, there's two separate parts of the number line that are filled in. If you were to write this in set builder notation, Again, you would need two separate inequalities. You would write x such that x is less than -5 or x is greater than 1. So notice this is different than the conjunction that we looked at previously, where we could, in the end, combine everything to one interval, one inequality. You can't do that here. You also have to pay super close attention to what word is between the two statements, and versus or. Because let me ask you a question. What if instead it said x is less than -5 and x is greater than 1? Now let's think back. When we had and, that means intersection. That's the overlap. So let me ask you, look at the number line. Where do you see both blue and purple overlapping? You don't, right? So if the word was and instead, you would actually have no solution. The empty set. You could write an actual empty set if you like. So be careful, okay? Because whether or not the word is and or, it will completely change your solution. All right. Don't fret, you're gonna get this down, no problem, with lots of practice. But if you want like a little summary, okay, or means union, join everything together, and means intersection, look for the overlap, okay? So if I were to give you like a cute little, let's scoot this over. If I were to tell you like what to take away from all this vocab and remember when you're solving, it's this right here, okay? Or means union, join everything together, and means intersection. You're looking for the overlap, okay? Good. So now let's solve some here, graph, and then we're gonna write the solution using interval notation. So the first one is 4 is greater than x, or x is greater than or equal to -3. I recommend, until you're getting really comfortable with these, put the variable on the left, just so your brain can digest it more easily. So instead of writing 4 is greater than x, isn't that the same as x is less than 4? Notice the inequality is still opening up, right, towards 4. So that means 4 is larger, but it just helps your brain translate it better. Or x is greater than or equal to -3. Okay. So this one's ready to graph. Here's -3, here's 4. X is less than 4, parentheses or bracket? Very good, parentheses. And shade which way? To the left. Okay, x is less than 4. Or x is greater than or equal to -3, parentheses or bracket? Yes, bracket. And then shade which way? To the right. Okay, so now let's look here. Notice the statement, or the word between these two statements, is or. So we're looking for the union. We're joining everything together. So our solution set is going to contain any part of the number line that we shaded in. Anything goes. Well, I see actually the whole number line shaded, don't you? I mean, there's a part that overlaps in the middle, but we're not looking for the overlap. We're just looking for any old thing that's shaded. So what is our solution? What's our answer? -infinity to +infinity. Did you catch that? Okay, what if instead the word had been and? Same two inequalities, but they said and. Well then, yes, then your answer would be just the overlap from -3 to 4. Do you see the difference? Hopefully you're getting the hang of it now a little bit. Okay, let's look at another one. Example B. I want you guys to pause the video, give B a try on your own, and then we'll go over the answer together in just a moment, okay? All right, good. Did you pause it? Give yourself the opportunity to try on your own. You know, it's really going to make a difference. Okay, here we go. Example B. So t minus 7 is less than -4. So I'm going to add 7. So this is t is less than 3. Or add 7 again. So now I have t is greater than 11. Okay, let's graph this. We need a little separation here, right? Okay, t is less than 3 or t is greater than 11. Here's 3. Here's 11. T is less than 3, parentheses or bracket. Why parentheses? Yes. Shade to the left. T greater than 11, parentheses, shade to the right. And notice the word is or. Okay, so our answer is going to be the union of everything that we see shaded on the number line. Well, again, I see two separate parts shaded, so I'm going to have to list out two intervals. First one goes from negative infinity to 3, union 11 to positive infinity. Did we get it? Wonderful, look at you guys. Okay, last one like this. G of x is less than or equal to negative 7, or g of x is greater than or equal to 10, where g of x is equal to 3x plus 5. So to start off, we have to replace g of x with what they gave us, and they told me g of x equals 3x plus 5. So that means 3x plus 5 is less than or equal to negative 7, or 3x plus 5 is greater than or equal to 10. Okay, so solving each one, I'm going to subtract 5. So 3x is less than or equal to negative 12. So x is less than or equal to negative 4 if I divide by 3. Or, same thing, subtract 5. So 3x is greater than or equal to 5. And then divide by 3. So x is greater than or equal to 5/3. Remember, leave it as a fraction. Don't switch to decimals unless you're instructed to do so. Stay in fraction land. So these are the two values we're going to put on the number line, negative 4 and 5/3. Don't freak out because it's a fraction. You just go, here's negative 4, and here's 5/3 because I said so. My number line, my world. Okay, x is less than or equal to negative 4. Parentheses or bracket? Good. Bracket, shade which way? To the left, yes. Bravo. Shade in that little arrow. Or x is greater than or equal to 5/3. Bracket again. Shade to the right. Notice the word here between the two statements is or. We have a disjunction. So I'm going to list out my solution as anything that I see shaded on the number line. Again, I have to write out two separate intervals. So the first one, always go smallest to largest, right? Follow the order of the number line from left to right. The smallest value I see shaded on the number line is going to be negative infinity up until negative 4 with a bracket, union, bracket, 5/3 up until positive infinity. Always parentheses on infinity. Remember that. Parentheses on infinity. Okay, how are we doing? Good stuff, right? Okay, now let's get a little fancier. We're going to revisit the idea of domains of functions. So recall the meaning of the domain of a function. It's the set of all values for the independent variable, usually x, for which the function is well defined, meaning you can plug it in and get a real number that makes sense. For example, the domain of f of x equals x plus 2 over x minus 5 is going to be what? Well, remember, anytime we have variables in the denominator, we got to make sure that the denominator doesn't equal 0. So in this case, we have a restriction. X cannot equal positive 5, right? And the way you write the domain is you say the set of all x's such that x doesn't equal 5. We went over this in a previous lesson. All right. Now, how would we represent this domain using interval notation? Because notice this is set builder notation. So how would you write the same thing in interval notation? Well, to figure it out, let's look at the graph. What does it mean x can be anything except for 5? What would it look like? Well, it would mean you'd shade the whole number line except for poor little 5, right? So you would shade in everybody except for 5. Poor 5. And open circles isn't used so much anymore. That was in all of my math books back in the day, but now on number lines, you'll see a lot more parentheses and brackets. So alternatively, to show that you're not including 5, you would have parentheses, right? Because we're not including it, and then another one here. So could you figure out how to write that in interval notation? You'd have to write 2 separate intervals, wouldn't you? You would go from negative infinity up until 5 with parentheses, not a bracket, right? We're not allowed to include 5. And then you go union 5 to infinity. And that's how you skip over a number using interval notation. You go up into the number with parentheses, union, and then you list the number again with parentheses. You get as dangerously close as you possibly can. Okay. Also, we can use this idea to write the domain of functions involving square roots. If you'll remember, only square roots of non-negative numbers are real numbers. So what that means is anytime you see that you have a square root function, you want to make sure that the radicand, the stuff underneath the radical sign, is not negative. Well, what's another way of saying not negative? That it's greater than or equal to 0. So you're going to set 8 minus 2x greater than or equal to 0. And this is your general rule. If you have f of x equals the square root of g of x, to find the domain, you set g of x greater than or equal to 0 and solve. Okay? That's general rule of thumb for square root functions or anytime index is even. Okay, so here we go. Let's solve this guy. 8 minus 2x greater than or equal to 0. That's no big deal. We've become professional at this. Let's subtract 8. I like to keep the variable on the left on these inequalities, remember. So negative 2x is greater than or equal to negative 8. Be careful, be careful. I'm going to divide by negative 2. Anytime you multiply or divide by a negative, the inequality sign flips direction. So x is less than or equal to positive 4. Ooh, okay. They want the solution in interval notation. So let's graph it really quickly. 4, bracket, shade to the left. So use this to help you write it in interval notation. You would start at negative infinity and go up until 4. Very good. And you can always check that it makes sense. Like pick a number that's in here. You could try x equals 0. Check if it works. Like check if you're allowed to plug it into your function. F of 0 is the square root of 8 minus 2 times 0. So square root of 8, that's fine. Now try something that's not in there. Ooh, let's try 6. F of 6 is square root 8 minus 2 times 6. So that's 8 minus 12, negative 4. Yep, that's not in the domain. Can't take the square root of a negative and get a real number. And then what if you're living dangerously? You're going to pick 4 right on the edge. Can you do it? We're saying it's part of the domain. It better work. So f of 4 is square root 8 minus 2 times 4. That's 8 minus 8. What's the square root of 0? It's just 0, right? 0 times 0 is 0. Yeah, that's fine, but that's it. You're pushing it. Don't even think about 4.1. It's not happening, people. All right, good job. That concludes the video. Coming up next is absolute value equations and inequalities. Just crucial skill to know how to solve those guys. So stay tuned. Give this video a thumbs up if you found it helpful, and please subscribe. I would really appreciate your support.